Go. All right, welcome to section 7-2, smack the desk, same outfit on. Just kind of keep rolling along here with our videos for chapter 7. Just like in 7-1, there's going to be 2 videos for section 7-2. You'll have a couple days to do these, so you should be in good shape to go. Today we're going to take care of, or in this first video, we're going to take care of the first 2, adding and subtracting rational expressions with the same denominator. And then we're going to talk about that least common denominator. So we're going to add rational expressions and subtract rational expressions in section 7.2. And the first part of it, they're just going to be like terms that we're going to use. So objective 1, add and subtract rational expressions with the same denominator. So we're essentially, remember, rational expressions, they're just fractions. So we're going to look at adding fractions with the same denominator. So if we're thinking about regular fractions, let's say we have something like 3/4 plus 5/4. It's just a normal fraction that you've seen in your lives, and you've grabbed this thing and you've grabbed it and you've done the adding fractions with the calculator. Remember, when you're adding fractions, you have to have a common denominator. Once you have that common denominator, you're in good shape. The denominator is always just going to stay the same when you're adding or subtracting them. That doesn't change. The denominator is always what the denominator is. And then you do the operation to the numerator. So 5 plus 3 is 8. So this is 8/4, which you could reduce to 2. So when you're adding or subtracting, you've got to have that common denominator. If you've got that common denominator already, just do the operation to the top or to the bottom. The bottom stays the same, okay? So let's say we have 3/4 minus 5/4. Well, the denominator is already 4. 3 minus 5 is -2. Now you reduce that to -1/2. Again, we're just subtracting the numerators. Denominator stays the same. So that's what we're really going to do with rational expressions. So if the denominators are the same, add or subtract the numerators. Place the result over the common denominator. What we'll do tomorrow, if they're different, you're going to have to find a common denominator. And then simplify always into lowest terms. Everything we do today is going to be the same. So if we have 7x over 9 plus y over 9, check to see if the denominator is the same. It is. It's 9. Since the denominator is 9, you're just going to perform the operation in the numerator. Denominator stays the same. So 7x plus y, you can't combine them. So your solution is just 7x plus y over 9. It can't be reduced, so you're done. 8 minus 14 over 3x cubed. 8 over 3x cubed minus 14 over 3x cubed. Our denominator is 3x cubed. Our numerator, 8 minus 14. 8 minus 14 is -6. Yeah, so we've got -6. Now notice you've got numbers on the top and the bottom. That can be reduced to -2 over x cubed. And that's your solution, because 3 goes into 6 twice, assuming you can reduce fractions. Right? Same answer they got. Next one. Denominator is the same. So if the denominator is the same, leave it like that. R squared minus t squared. You're going to be a little bit tricky with this one, but so then you got r plus t on the top. Now you have to make sure it's reduced, and this one's a little tricky because r squared minus t squared is a difference of squares. So that's r minus t, r plus t. So you do have to look to see. So we've got r plus t in both the numerator and the denominator, so they cancel out. So you're left with 1 over r minus t as your solution. So you just got to be careful to make sure you reduce it and put it into its lowest terms. Kind of the same thing with this one. We're going to have a 6 plus x on the top, and on the bottom, x squared plus 3x minus 18, because the denominators were the same. Now you need to look at, I wish it would let me erase that. There's no eraser on here. Doesn't. So we'd have to factor this bottom. This factors into x plus 6 and x minus 3. So those things are the same, leaving you with 1 over x minus 3. And they're not the opposites of each other because there's a plus sign in there. So that's your solution for part D. So moral of the story, when you're adding or subtracting with like terms, the denominator stays the same. You do the operation that you're supposed to do in the numerator, and then look to reduce it like we did in section 7.1. Okay? Kind of the moral of that story. So when you are adding and subtracting them, you have to have what we call a common denominator. Like I said, well, what happens if you don't have a common denominator? You have to be able to find the least common denominator, and that's the second part of this lesson. How do we go about finding that least common denominator? So in order to do this, you are going to factor each denominator. And then you're going to find the least common denominator. It is the product of all of the different factors from each denominator with the factor raised to the greatest power that occurs in any denominator. What the heck does all that mean? Essentially means you factor the denominator. You start on the left-hand side and you just start writing things down. And you just keep going. If it's in the first one and in the second one, you don't have to write it down again because you already have it. If something is squared and then it's just to the first power, then you take it to its greatest power that you have. So if we're going to find the least common denominator of this, okay, we look at kind of the 10. So we've got 10 and 15. So we got to figure out, okay, what's a common thing that they have? Well, we could do the factor 3 for 10. 10 is 2 times 5. And 15 is 3 times 5. So really, we could write this as 2 times 5, a cubed b to the 5th. And we could write the second one as 3 times 5, a squared b to the 6th. So we start on the left-hand side and go to the right. So we've got a 2, we've got a 5, we've got an a cubed, and we've got a b to the 5th. Now we go to the next one. We've got a 3 sitting there, and I don't have a 3 written down, so I have to write times 3. I've got a squared there, but I've got a cubed there. So cubed is bigger than squared, so I don't have to add any more a's in there. I've got b to the 6th and b to the 5th. So that means I've got one more b on this one. So it means I have to add another b in there because there are 6 there. I'll make that easier in just a second. So then what we end up having here is 2 times 5 times 3, which is 30, a to the 3rd, b to the 6th. And that's your least common denominator for this problem. Now, in the last thing, it said it's your greatest exponent. Honestly, I wouldn't write all of this down. Okay. I would look at the a's and say there are 3 a's here and 2 a's there. That means I have to have a to the 3rd. There are 5 b's here and 6 b's here. That means that needs to be b to the 6th. And then I just look at the numbers and say, okay, what multiple do 10 and 15 have? 30. Okay. That's a lot of writing to get to that answer that you don't necessarily have to do. Okay, so that's the least common denominator for that set. Okay, let's see what they wrote. Say factor, and they dig in. They did it the same way I did this time, and you can see what they have. So part B says, what's the least common denominator for z and z plus 6? Well, factor each of them. Can you factor z? No. Can you factor z plus 6? No. So you start on the left-hand side and then rewrite what's not there. So we've got a z. Now understand that z plus 6, that z is different because it's got 6 added to it. So my second factor for this is going to be z plus 6. So this is the least common denominator for that. Z times z plus 6. These two z's are not the same thing because of that plus sign in between there. So you have to keep that in mind. That's a common error that's made. Okay, and you have to distinguish those things. for the next one. We've got m squared minus 16, m squared plus 8m plus 16. So we have to factor. So m squared minus 16 is m minus 4, m plus 4. M squared plus 4m plus 8m plus 16. So we've got our 16 and 8, so 4 and 4. So that's m plus 4, m plus 4, which is the same thing as m plus 4 squared. So now when we're finding the least common denominator, I start on the left-hand side. That's right there. So I've got m minus 4. The next thing I have m plus 4, but I don't have any more. Now I look at my other one, and it's m plus 4 squared. So my m plus 4 there can just be squared. That's the least common denominator of those two. Okay, this is exactly what we had. Okay. D. So we've got x squared minus 2x plus 1, and x squared minus 4x plus 3, and 4x minus 4. So we're going to factor. So x squared minus 2x plus 1, that factors into x minus 1 times x minus 1. You can do the x thing if you need to. X squared minus 4x plus 3, x minus 3, x minus 1. Again, you can do the x thing if you need to. 4x minus 4, I can take out a 4. That leaves me with x minus 1. Start on the left-hand side. We've got x minus 1, but it happens twice, so I can make that squared. I go to the next term. It has x minus 3, so I have to put an x minus 3 in there. I've got the x minus 1 that's here, but I've already have it, so I don't need to rewrite it again. I go to the third term. I've got a 4 there, so I have to put the 4 in there. It's just nice to put it out front. X minus 1, it's already there. I don't need to put it in there again. There's my least common denominator. 4 times x minus 1 squared times x minus 3. And again, we're going to need this when we start adding and subtracting with unlike denominators. This is the key with unlike denominators. That's why we got to be good at this. Okay? And they've got it sitting down there somewhere. And that's what we had. Okay? So that would lead us to the third objective, which we're not going to do in this lesson. So you've got the first part of it. So this is 7.2a. If you want to stop, the video is going to stop again. I would go off and do the 7.2 homework assignment, and then come on back and watch the 7.2b video. After you finish that, then do that one.